Okay, let's begin this lesson. It's section 2.6 part B. We've already been graphing piecewise functions on section 2.6, but we also have graphing absolute value equations on that same section. So we're calling this part B. And before we even begin, I mean, you have these notes typed up right here in front of you, but before we begin, let's understand this. An absolute value equation, when graphed, looks like a V. All right, it might be a V opening up or a V opening down. That's what I'm saying here. It could be wider or narrower than usual, right? So it could be a really wide V, could be a narrow V, and we'll get to that in a little while. So we do need to memorize this form right here, okay? Y equals A, absolute value of x minus h plus k. Let's understand this. The A value is just a number, okay? The H value is just a number. And the K value is just a number, okay? And that's what I try to explain down here. It tells us that the coordinate HK is the lowest or the highest point of your absolute value function, which we know is like a V, depending on if it opens up or down. Tip, think opposite on H and take K for what it is. So the reason why whatever you have here as a number you think opposite is because of this minus sign. Okay, so for example, let's say I had y equals 2 absolute value of x minus, let's say 3 right here, and then plus 5. Okay, so this is an equation that's in this form, okay? And the A value is 2. The H value, this H value, you have to think opposite of what you see here. So if it says x minus 3, the H value is really positive 3. And the K value, you take it for what it is, okay? So the reason why we're thinking opposite on H is because of the minus sign that's in the form, okay? So we think opposite of what we see here. So instead of minus 3, our H is going to be a positive 3. And the K value, take it for what it is. So we're going to take that HK value, and that will be our highest or lowest point of our vertex. Not of our vertex, of our absolute value graph. So let's continue reading here. If A is positive, then it opens up. So if this number out here is positive, the V is going to open up. Okay, so this 2 right here is going to cause it to open up. HK is where you begin your graph, and then you will rise and run from that point. Okay, so you're thinking, well, where am I going to get the rise and the run? I don't see an M up here, but it says right here, A is kind of like your slope, rise over run. Okay, so what all of this says pretty much, or what I want you to get out of all this, is to think about this. The steps to graphing absolute value equations, it's as easy as this. Step 1, graph HK. But remember, think opposite on H. So whatever you see, if you see a minus 3, that's actually going to be a positive 3. And then after you plot that point on the graph, rise and run from that point according to A. So let's pretend that the A is the M value, which is rise over run, the slope. So those are great steps to know, because if you don't know those steps and you don't memorize this form up here of y equals A, absolute value of x minus h plus k, if you don't memorize that, then you're going to be stuck with treating it like a function, which there's nothing wrong with that, right? Making an xy table. So right here, I want you to graph using an xy table. Everybody make an xy table. And let's plug in some inputs. And let's plug in some negative and positive values. So like negative 3, negative 2, negative 1, 0, 1, 2, 3, okay? So when I plug in a negative 3, right in here, the absolute value of negative 3 is 3, right? The absolute value of anything ends up being positive. So then we go negative 2. The absolute value of negative 2 is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. So on an input-output table, you end up producing coordinates. So let's go to the coordinate negative 3 and 3. Which is up here. Let's go to the coordinate negative 2 and 2, negative 2 and 2, which is right here. Let's go to the coordinate -1 and 1. So -1 and 1 is right there. Let's go to the coordinate 0, 0, which is right there. Let's go to the coordinate 1, 1, 2, 2, 3, 3. As you could see, this is a V, right? It's like a graph that looks like a V. So it does have a lowest point. It goes and it continues in that direction forever. It goes and it continues in that direction forever, okay? So that took a while. So let's not do that because it takes too long. Let's understand and memorize this right here. Y equals A, absolute value, x minus h plus k. Now if we look at it that way, let me actually rewrite it right here. There it is what we have to memorize. Again, y equals A, absolute value of x minus h plus k. Think opposite on h because of this minus sign. Take k for what it is because it's a plus sign, not a minus sign. Anyhow, if I asked you what value right here on this equation, this absolute value equation, what value of this absolute value function is A? What's the A value? If there's no number, it's not 0 because 0 times this would make the whole thing 0, right? The A value is actually 1. Okay, so it's kind of like if the slope, remember we said A is kind of like slope? It's kind of like if the slope were up 1 over 1, okay? If I asked you, what is the highest or the lowest point of this absolute value function? Now remember, the highest or lowest point, it depends if your V goes like that or if it goes like that, right? This would be a lowest point, this would be a highest point. And how do we know that highest or lowest point according to our notes from above? It is the coordinate HK. So could I see a coordinate HK? And again, think opposite on H and take K for what it is. Now H is supposed to be inside the absolute values with the X, and there is no number that's added or subtracted here, so you could think of it as -0 if you wanted to. So the H value truly is 0. Let's put a 0 right here. Now the K value, you take it for what it is, and the K value happens to be the number that's added or subtracted out here outside of the absolute values. So it's a -2 that's on the outside, so that is a -2. So the HK value is 0, -2. So let's go to that highest or lowest point. I'm not sure what it is yet. 0, -2 is right here. Now it might be a lowest point if it's going like this, or it might be a highest point if it's going like that. What tells you if it opens up or down according to the notes above? It said the A value, if it's positive, it opens up. If it's negative, it opens down. Not only that, you treat it like a slope, right? So you graph this point and then you rise and run according to your A value, which is like your slope. So you're going to go up 1 over 1. Why am I going up? Because this outside value is +1, right? So you go up 1 over 1, up 1 over 1, and so on and so on. Now we know that the line, it's not a line that goes down forever. This was your lowest point, so it has to bounce back up and go in the opposite direction. So there's your absolute value function. Let's try another. Number 3. So what is the highest or the lowest point here? Remember, it's H and K. So H, K. Think opposite on H, take K for what it is. Okay, so you should be saying that the H value is +2 because you have to think opposite on H, right? Here's your A out here in the front, which is 1. Your H is +2, and your K is 0 because there is no number that's added or subtracted on the outside of the absolute values. So the K value we said was 0. Let's plot that point, 2, 0. Let me do it in red. And now from that point, we rise and run according to our A value, which is the number out here. And again, the slope is 1 over 1 in this case. So you're going to go up 1 over 1. Now, if this outside value would have been a -1, like a -1, then you would have been going down 1 over 1. Make sense? Right here, it's +1, so it's opening up. That's why if the A value is positive, it's going to open up. If the A value is negative, it's going to go open down. Same thing with the slope. If the slope is positive, it's going to go up from left to right. If the slope is negative, it's going to go down from left to right. However, we know that this is going to be a V. So not only do you go up 1 over 1 this way, you could also go up 1 and over 1 this way to start creating your V. Okay, and you could continue to go up 1 over 1 and up 1 over 1. Or you could just do one whole side and then just mirror it over. Like imagine a reflection line right here and mirror it over to the other side. So this guy was 2 units away, so go 2 units away this way. And this one's 3 units away. And there's your perfect absolute value function graphed. Okay, so what I would like you guys to do right now, let me do one more and then I'll have you guys try it on the next one. Okay, so I'm going to graph this one. The A value is 1, right? The A value is the value that's outside in front of the absolute values. The H value, you have to think opposite of what you see right here. And the K value, you take it for what it is. Okay, so what is my HK value? My HK value is -1, 2. That's my H, that's my K. I thought opposite on H. It was a positive 1. My H is a -1. Okay. My A value, which is kind of like my slope, is actually up 1 over 1. So again, the HK is the highest or the lowest point of your V of your graph, that depending on if it opens up or down. And if your A value is positive, the V is going to open up. If the A value is negative, the V is going to open down. Your graph is going to open down. So let's go to the coordinate -1, 2. -1 on the X, 2 on the Y. There it is. And I'm going to go up 1 over 1. So up 1 over 1. Continue to go up 1 over 1. Continue to go up 1 over 1. Go back to your lowest point, right? We said that the HK value is your lowest point. So let's go up 1 and over 1 in the opposite direction. Opposite direction. Up 1 over 1. And there's your graph. It's that simple. Okay. So I would like you to try and do number 5 yourselves. So please hit pause at this moment and try it, and then unpause it and you'll see the answer. So there's the answer. Think opposite on H, which is 2. Take K for what it is, which is -3. So you go to 2, -3. This happens to be your lowest point because the A value is positive, which means it opens up. From this lowest point, you go up 1 over 1, up 1 over 1, up 1 over 1. You go back and do the same, but in the other direction because we know it's a V. Up 1 over 1, up 1 over 1. Or again, you could always just reflect it. This is 1 unit away from the axis of symmetry, so you go 1 unit away, 2 units away, 2 units away. And notice that I kept going up 1 over 1, and it looks like the V is weird, like this side's really long, this one's short, but it's not. Remember, the graph continues to go forever. Okay, so it goes forever. It's just you're only seeing this portion of it because this is a limited graph, 4 by 4, right? It's 4 units and 4 units. So that's why it looks kind of weird. I hope you guys all got that right. And we do have some more questions here. And this is actually part of the homework, right? This is notes and homework, notes and practice. So let's take a look at number 6. There's obviously no H inside the absolute values with the X. And there is no K at the very end. So what is our highest or lowest point? What is our HK on this one? Our HK is 0, 0. So this is either the highest point or the lowest point, but we know that the A value is positive, so you know that that's the lowest point. So we're going to be going up 1 over 2. So you go up 1 over 2, up 1 over 2, and you just keep going. But then you go back to your lowest point and do the same in the opposite direction, up 1 over 2 this way. And you end up with that wider V, that wider graph. Put arrows on it, and you're good. Okay. So it definitely, the regular V's that we used to get before of up 1 over 1, it definitely got wider because this A value got smaller. Instead of 1, it was a 1/2. So the smaller the A value gets, the more wide that your V is going to get. On the contrary, if your A value is bigger, then it's going to get more narrow. Okay, so watch what happens here. Again, the H and the K are not there. So it's 0, 0, which will be the origin, which will be your lowest point. And what do we do from that point, from the HK point? You rise and run according to your A value, which is like your slope, right? So you're going to go up 1, 2, 3 over 1, and you're going to put a dot right there. As you could see, and if you do it in the other direction, up 1, 2, 3, and in the other direction, this V is a lot more narrow than your regular V. You put some arrows on it and you're done. Of course, you could have continued to rise 1, 2, 3 over 1 and you'd be out here. That's why I pointed it in that direction. Same thing over here. But as you can see, the V is a lot more narrow. So we're going to have to learn this anyways, guys, so you might as well learn it now. The A value that's out here in the front will cause either a vertical stretch or a vertical compression. I know that sounds weird. It's the first time you hear those words, but it really just makes your graph either wider or narrower. Okay, so the closer it is to 0, the wider it's going to get. If you actually had 0 right here, then it wouldn't be even an absolute value function anymore. It'd be a totally flat line. So the closer you get to 0, the closer to a flat line it gets, the wider it gets. The further away it is from 0, the more narrow that your V-shaped graph will get. Okay. Number 8 is interesting. It's the first one that we actually have a negative as our A value. So again, there is no H inside the absolute values with X. So you could think of it as minus 0, plus 0 out here because there is no K. So again, the HK value is 0, 0. That's either your highest point or lowest point depending on your A. So 0, 0 is our lowest point because the A value this time is negative. Okay, so we really have a negative 1 over 1. So according to our notes, you have your highest point here or lowest, and from this point you go according to your slope, according to your A value, down 1 over 1. So you put a dot right there. And you know that it continues to go down 1 over 1, down 1 over 1. And you know that this is a V. It's going to be a graph of a V, a regular V, and it's going to end up opening down because it's negative. So you're going to have to use that same pattern of down 1 over 1, but in the opposite direction, so you could get that perfect graph. So what was the difference between the A value being positive or negative? It depends. If it's positive, it opens up. If it's negative, it opens down. So number 9 is an interesting one because it opens down. Why does it open down? Because the A value is negative 1 and you have your H and K. So we know that the HK value, where you think opposite here and take this for what it is, we know it's going to be the highest point because this V-shaped graph is going to open down. Okay. So what is the HK? Well, the HK happens to be positive 1 and positive 3. Think opposite on H, that minus 1 becomes a positive 1, and you take K for what it is. It says plus 3 right there, so your K is going to be a positive 3. So let's go to the coordinate 1, 3, put a dot right there. And we know that the A value is negative 1 over 1, which means it's going to be going down 1 over 1, right? It's kind of like rise over run. Negative 1 rise, it means you're going to drop 1, and you're going to go over 1, okay? So if you drop 1, go over 1, and you continue to go drop 1 and go over 1, drop 1 and go over 1, drop 1 and go over 1. And you do that in the opposite direction as well. Remember, this is your highest point. Your HK is your highest point. So you're going to do down 1 but over 1 this way. You never do that when you do regular lines, but we're doing that right here on absolute value functions. Another way of doing it is kind of like doing a reflection line right here. You could call this the axis of symmetry, and just reflect your points over it. You don't have to do this, but you could if you wanted to. Just, well, it's 1 unit away, 1 unit away. 2 units away, go 2 units away. 1, 2, 3 units away, 1, 2, 3 units away. You could do this if you want, because we're going to end up practicing this with parabolas in the future anyway. So there's your graph. So number 9 is almost identical to number 10. So I'm going to skip number 10. You guys could do that as homework. And I'm jumping to number 11. 11's cool. Why is it cool? Because it has an A value of -2. So if I were to ask you, does this open up or down? You should say it opens down. Why? Because it's a negative. So what's your HK value? Everybody should know your H, think opposite of that, which is a -3. And your K value happens to be +3. So let's go to -3, +3, which is up here. And you could start rising and running according to your A value, which is kind of like your slope. So you're going to go down 1 over 2. I mean down 2 over 1. Sorry about that. Down 2 over 1. So you go down 2 over 1. Continue to go down 2 over 1. Down 2 over 1. And remember, it's kind of like a reflection line called the axis symmetry right through that highest point. And you could just map them over to the other side. So this one's going to be off the graph. You don't have to actually do this guy right here. Okay? But we do have our perfect graph. Just put an arrow right there, and this one goes down, put an arrow right there. So I think, and I hope we get the hang of it. I want to expect you guys to do 10, 12, and 13 for homework, and also 15. I'll do 14 with you guys right now. In order for you to graph these, you have to have it in function form, which would mean to get y by itself. Okay, so let's get y by itself by doing some math. Let's first get rid of this +6 by subtracting 6. And you can't really subtract 6 here with the 4 because that's being multiplied. So I'm just going to put the -6 over here at the very end. I'm going to subtract 6 over here at the very end. Let me rewrite what I have. I have a 3y equals 4 absolute value x minus 2 close absolute value with the -6 at the end. And now I'm going to divide everything by 3. So when I say divide everything by 3, this divided by 3, this divided by 3, and this divided by 3. So notice I'm not really messing with the inside of the absolute values. Okay, this is kind of like one term, like if it were a 4y or a 4z, you're dividing just this term by that value. So we're going to divide the 4 by 3, and let's rewrite our function form absolute value function. So the 3's canceled. We have y equals, a 4 divided by 3 you can't do, so that's okay. Let's leave it 4 divided by 3. And that's great because this is our A value, which we're going to call our slope, or we're going to use it as a slope. And it says x minus 2, but we need to think opposite of what we see here. So we're going to have to think of it as a +2. And at the very end, we have a -2 as well. But this minus, you keep it for what it is, right? You don't think opposite on k. So our lowest point here, our HK value, will be +2, -2. Think opposite on H, take K for what it is. +2, -2. There it is, +2, -2. Let's go to +2 on the X, -2 on the Y. Put a dot there. We know that this V is going to have a perfect reflection line right through this on both sides of it. That's called the axis symmetry. You don't have to do that line, all right? You could just rise and run according to your slope, and your slope here is your A value, which is 4 over 3. So you're going to go up 1, 2, 3, 4 over 1, 2, 3, and put a dot right here, right on the edge. Oops, let me put it in green. In red. And since you have that reflection line, you could just see how far it is from the reflection line and go in that direction, those units, but in the opposite direction. And there's your V. Put some arrows on it, you're done. So do the same for number 15, and I should post another video explaining those homework questions for you, but I want you guys to try this on your own right now and then check it later on the other video.